All right, welcome to Chapter 10, Part 1. Today we're going to talk about simple experiments. So we've been talking about correlational studies, and now we're going to get into simple experiments. What makes something a simple experiment is that it has one independent variable and one dependent variable. Simple, keeping it simple. In the next few chapters after this, we'll talk about making it more complicated. But right now we're going to talk about simple experiments. Let's start with the review question, though, based off of the stuff we talked about last time. Which of the following is true? A, experiments cannot include a mediated hypothesis. B, experiments cannot include a moderated hypothesis. C, correlational experiments cannot predict moderated hypotheses. Or D, experiments must have a comparison group. Which one is true? D, experiments must have a comparison group. That's the one that is true. Remember, whenever we do a manipulation, which we'll get to in just a minute, to remind you, whenever you do a manipulation, you got to have at least two levels, right? Normally, you think about this kind of like as a control group, experimental group, but you've got to have that. Now, experiments can have mediated hypotheses, and experiments can definitely do moderated hypotheses. Correlational experiments, I just kind of made that up, so that doesn't make much sense. So anyway, that doesn't make a lot of sense. Anyway, let's do a little bit of review of what the difference is between mediation and moderation, just so you have it in your brain. So first, mediation is when variable A causes variable B and variable B causes variable C. That is a mediated hypothesis. A mediated hypothesis. So what does that look like? Let's go ahead and review what that looks like. So a mediation looks like this. Let's see if I can draw it out for you. Mediation is going to be, I have one variable. Let's call that education. Okay? Let's say that education, we're interested in the relationship between education and happiness. All right? We know that education and happiness are correlated, but does education by itself cause the happiness? Well, let's say we ran a study and we found that people who are more educated earn more money. That is, they have more financial stability. So education causes financial stability, and financial stability is what causes happiness. You don't have to have a fancy degree as long as you have financial happiness. Education really just causes financial happiness, and financial happiness is what causes, financial stability is what causes happiness. If that was true, which by the way, I don't think it fully is, then education causes financial stability causes happiness. Education by itself does not cause happiness. It has to go through financial stability. That would be mediation. You would use a mediation analysis like we talked about in the last chapter to test that. Now that's very different from moderation. In moderation, you have a variable that has a relationship with another variable. So the effective A, so this is the first variable there, effective A on C, which is what we have right here, depends on another variable, this other variable over here. So this is A, C, and B. So let's go ahead and fill this in. So variable A, let's let that be painting, all right? Painting. Okay, so let's say you take up the hobby of painting. And painting causes happiness. Again, we'll have the dependent variable be happiness. Okay? Painting affects your happiness, but it depends on, so what this is saying is that the relationship between painting and happiness depends, right? So it's not always going to make you happy. That's what it's saying. It depends. Painting's effect on happiness depends on whether there is lead in the paint, the presence of lead. So, painting, you ask, how does painting affect happiness? Well, depends. If there's lead in the paint, then painting makes you unhappy. If there's not lead in the paint, then painting makes you happy. That is a moderated design. Mediation, it's got to go through. Moderated, it depends. That's the way you should look at those. Now, one thing that you should note is that sometimes we do tests and we're looking at something like a moderated hypothesis. And we might say, oh, well, I think that I've got these two variables in mind, and I think they're both going to affect a couple of things. So let's say All right, let's say that the dependent variable is attractiveness. All right, the dependent variable is attractiveness. Let's say that I think that being from Nebraska makes you more attractive, right? But then I think, hey, you know what? There's another variable that's involved here, and that's glasses. All right. Does being from Nebraska affect your attractiveness? Does that depend on whether or not you wear glasses? Or are they just separate effects? Being from Nebraska makes you more attractive. Wearing glasses makes you more attractive. They both make you more attractive. What I have right there is not a moderated hypothesis. It's not moderated. It doesn't say depends. Nothing depends on anything else. It's just saying Nebraska causes attractiveness, glasses causes attractiveness. Nothing depends on anything else. This would only be a moderated design if being from Nebraska affects attractiveness, but it depends on whether you wear glasses, right? If you wear glasses and you're from Nebraska, you're attractive. If you're from Nebraska but you don't wear glasses, then it has no effect on your attractiveness. That would be moderated. But if you just think that being from Nebraska affects your attractiveness, and so does wearing glasses, then that's not a moderated design. By the way, it's also not a third variable problem. Third variable problem is a separate issue, okay? A third variable problem would have to say that wearing glasses causes you to be from Nebraska and wearing glasses causes you to be more attractive, and that's not what's happening here. A third variable problem, in that one, the variable is causing, variable B is causing both A and C. So for example, let's say that liking football, let's say that we did a study, we found that liking football let's try and get this to work, come on. Trying to get my pen to work. Liking football is associated with being kind. Right? So I took this study and I found that, wow, the more people liked football, the more kind they were. Wow, it must mean that football and kindness really affect each other. Well, what if you had this third variable, which is being from Nebraska? And by the way, people from Nebraska are known to generally be quite kind, right? Whether you think I am, it doesn't matter. But what if being from Nebraska caused you to like football? And being from Nebraska also caused you to be kind? It really had nothing to do with this. There's no real relationship between football and kindness. It's all about Nebraska causing football liking and Nebraska causing kindness. It really is not about football being affected by kindness. That would be a third variable problem right there. Okay. We need to move on and talk about experiments because the chapter is about experimentation. Now remember, when we're trying to figure out whether something causes something else, correlation doesn't equal causation. However, experiments can show causation. I didn't say that all experiments do show causation, but experiments can show causation. And the aspects of causality, the criteria for causality, include covariance, temporal precedence, and internal validity. That is, do they covary? Does one come before the other? And is there no other alternative explanation? That's what we're getting at here. So let's think of an example. Now we're doing simple experiments in chapter 10. Simple experiments means we're going to have one variable and one variable, two variables. But in this one, we're looking specifically at a causal relationship. So let's say that we're looking at, we think that stress causes anxiety. All right. Let's say that we think that stress causes anxiety. So the hypothesis is the more stressed you are, the higher your anxiety. Okay? That's what we're looking at. Covariance means as stress goes up, then anxiety would need to go up. All right? Temporal precedence means that the stress has to come first. Okay? If people were more anxious first and then we measured the stress, then we don't have the temporal precedence. We can't say stress causes anxiety because, there's no temporal precedence. So in this case, we have to make sure that the stress comes before the measurement of anxiety. And internal validity means there's no other alternative explanation that would make sense for these variables. So how do experiments do that? What we're going to do is we're going to talk about some of the basics of the experiments, and we're going to talk about how we would get to that point. So the first thing we need to understand is independent variables, dependent variables, and control variables. We've talked about this before, but we want to make sure that we understand this. An independent variable is the one that causes the change in the dependent variable. So in the example that we just barely did, we have stress causes anxiety. All right? Stress causes anxiety. Independent variable is stress. An independent variable has to be manipulated. And a dependent variable has to be measured. An independent variable, it's independent because the researchers change it, they manipulate it. The dependent variable depends on the independent variable. A control variable is something that you want to control. Now, it's not in the hypothesis yet, but let's say that there's another variable out there that we know has to do with anxiety. So let me put it up out of the way so that it's easier to see. We got this other variable over here. And we know that besides stress causing anxiety, we know that there's some other things that are related to anxiety. And so let's say that that includes medication. We know there are certain medications that can also cause anxiety. So in our study, we want to make sure it's the stress that's causing the anxiety, not medication. So control variables, when we say to control something, we're saying we want to get rid of the effect of anxiety, or sorry, medication on anxiety, right? We want to make sure that medication is not different in different levels of the stress, or that medication is really not causing the change. We want to make sure that our manipulation is only manipulating stress, and that everything else, as much as possible, is being controlled, so it's at least equal in all the different groups that we're going to be in. So a control variable is not a separate variable in the hypothesis. It is just something we're trying to control. And actually, in reality, we're trying to control all the other variables besides stress on anxiety. We're trying to control everything if we can. And so there's certain things that we have to control more overtly than others. All right. So a manipulation. So remember, stress causes anxiety. That's what we're saying. So manipulation, here's the stress that we're trying to manipulate. Okay? Here's the stress. How do we change the stress? This is the manipulation. Manipulation is one of the kinds of operationalizations. There are two kinds, manipulations and measurements. Those are the two kinds of operationalizations. A manipulation means that we, the researcher, cause a change in that variable. And this particular variable is stress. So what you're thinking is, hey, how can we change stress in someone for the experiment? The different groups that you put people in, or the different levels of stress, those are called levels. And generally, we put those people into different groups. So one way to think about this is like with a control group or a treatment group. All right. So one way that we could manipulate stress. So let's say that we, the researchers, are going to manipulate stress by making students take an impossible test. All right. The problem is we can't make all the students take the impossible test because we don't have a comparison, right? We don't have anything to compare it to. That doesn't work, right? If we did that, then we would just be controlling the amount of stress because everybody would be stressed. So instead, often what we do is we have one group that has no test at all. And we have another group that has impossible test. All right. This would be two levels of our manipulation. Okay, two levels of the independent variable. The people who took the impossible test should have more stress than the people who took no test. The control group, what makes it a true control is just nothing, right? We don't do anything to them, we just leave them, right? And then we measure how anxious they are. Whereas the other group, we give them an impossible test to manipulate their stress, then we measure how anxious they are later on. In a control group, oftentimes we will have a placebo instead of a pure control. A pure control is just don't do anything to them. But another one would, instead of being no test at all, we have this be, we have them take something like a test, right? Because we want them to experience everything, including anything that's like an expectation. So instead of an impossible, instead of no test at all, instead of no test at all, we can do a very easy test, right? Easy test. Now, is that a control group? Well, it depends on how you look at it. In reality, with an experiment, you don't have to worry about control group, experimental group. That doesn't matter, as long as you have different levels of the manipulation. The easy test might have more stress than nothing, but it has a lot less stress than the impossible test. Okay? Well, what if we had a third group that not only did they have an impossible test, but they had an impossible test plus they had their the teacher watching them, right? So not only were they given the impossible test, but they also have the teacher staring at them, watching them while they do the whole thing. So the easy test is very low stress. The impossible test is higher stress, and the impossible test plus people watching you, that's a much higher stress. In that case, we would have 3 levels. You can have as many levels as you need, but just remember the more levels you have, the more comparisons you have to do statistically later on. Manipulation just means that we, the researcher, are changing the amount of the independent variable. And you have to have at least 2 levels. Have to have at least 2 levels to have a true manipulation. If you only have 1 level, then all you're really doing is controlling the amount of stress because everybody feels the same amount of stress. In this case, we know that the people in the easy test group have less stress than the people in the impossible test who have less stress than people in the impossible test plus being watched. When we do designs of an experiment, we do the manipulation either independent groups or within groups. So remember, we have these 3 groups, these 3 levels of the manipulation. By groups, I'm talking about levels of the manipulation. So the design in this case talks about how we distribute people into the groups, which means how we assign them. Assignment is how we put people into groups. In an independent groups design, which is also called a between subjects design, so we don't like to call people subjects as much anymore. But in between subjects is actually the more common way people say this. In an independent groups design, what you do is you randomly assign people to either be in the easy test group, the impossible test group, or the impossible test plus being watched group. It's independent because the people who take the easy test will never, ever take the impossible test. Or the people who are in the impossible test will never be in the impossible plus being watched group, right? Those are independent groups. They're totally separate, all right? Generally, more often than not, we tend to be doing independent groups. You're in this group or that group. You can also do the design. You can also do design as within groups, or also called within subjects. What that means is that instead of one group getting the easy test, one group getting the impossible test, and one separate group getting the impossible plus being watched group, instead what happens is each participant gets all 3 levels of the independent variable. And within groups, all the participants get at least more than one, but almost always it's all levels of the independent variable. So what that would mean is that if I was a participant in this study, at one point I would take the easy test, and then you would measure my anxiety. Then I would take the impossible test, and you'd measure my anxiety. Then I'd take an impossible test plus being watched, and you'd measure my anxiety. Okay, within groups means that each participant gets all the levels of the independent variable. Now, technically, there are ways to do it where they don't get all the levels, but almost always they do, because that's generally how we do this. All right, so random assignment. Okay, random assignment. Remember, assignment is how we put people into groups in an independent groups design. Okay. Only use random assignment if, which one of these? So only use random assignment if you only have one independent variable. Only use random assignment if you have at least two independent variables. Only use random assignment if you have at least two dependent variables. Or only use random assignment whenever you have an independent groups design. It doesn't matter how many independent variables you have. And the answer is we use random assignment whenever we have an independent groups design. Always use random assignment. And the reason why we always use random assignment is because it helps us control all the other variables, all of those things that we want to control, those other things that could be what we call confounds. And we'll talk more about that in the next section.